Let's make a summary then of Kirchhoff's rules. The voltage rule we've took before. If you have any closed loop and you sum the potential differences across each loop in the proper way, the way we showed in the previous video, so go back to that video to see exactly how it's done, you get VA minus VB, VB plus VB minus VC plus VC minus VD, and so on, so that in the end everything cancels out. That's what the voltage rule says. And then we said, well, we need to figure out then how to get the potential difference across different kinds of elements. If you have an ideal wire, like from here from D to E, there's an ideal wire. What if you have a real a resistor? How would you get the potential difference across it? What if you have a source of EMF? How would you get the potential difference across it? So the next thing we need to know is how to get the potential difference across different elements. So we showed, for instance, for a resistor, how to get the potential difference across the resistor. The current, which we remember, current doesn't have a direction, but we put an arrow on the current to point in the direction of the electric field, which is the direction of J, and the current always then goes from high potential to low potential. And so that's how we can get the potential difference across a resistor, by knowing what the direction of the current is. So we showed for ideal wire the potential difference is 0. For a resistor, depending on the direction of the current, you get either a plus or a minus. And an ideal source of EMF, how to get the potential difference across it, depending on the location of the positive terminal. And so once you know how to get the potential difference across different elements, and you know Kirchhoff's voltage rule, then you can make the loop equation for any kind of problem. The last thing you need to know is how to use the junction rule. The junction rule says that any currents going into a junction equal to the currents going out, the sum of the currents going out. So if you apply the Kirchhoff's voltage rule plus the current rule, you'll be able to do any kind of, solve any kind of circuit and get the currents in any kind of circuit.